Morning everybody, welcome back. Saturday shop day. Today I'm going to work on machining a motor mount. So not really sure how long this is going to take. I feel like it could take a little bit of time, so I don't know if we'll get more than one done, but we've got our 3D printed motor mount here. This is going to be the left side one, a little bit simpler to make than the right side one, so I'm going to start with that. We got our chunk of 6061 2x2 flat bar, or square bar I guess rather, and so we're going to take this out to the milling machine and see if we can turn it into this. Should be a fun little project. I love making this kind of stuff. That's it. I don't know, we'll see how it goes. I'm feeling pretty good about how it'll go, but it is a rather large chunk that we're going to use to make this, so still better off than the rear motor mount, which we're going to have to make coming up here, which is, you know, going to probably be 4 or 5 times the amount of work as this. So anyway, that's it. See what we can get done on this today, and if this goes real smooth, we'll see what else we can throw in the mix. Alright, so we're out here at the mill. We got our block in the vise. First thing we're going to do is get everything squared up. Nice clean piece to work with. So we're going to go ahead and throw our little fly cutter in here. And we're just going to square up our first edge and then flip it all around, do all our squaring, and get a nice piece to start with. Really nice surface finish there. Deburr these corners and we'll flip it over to the other side. You can see, nice square cut, looking good. Alright, so we got both ends cleaned up. Knock off the little burrs just with a little hand file. Alright, so we got our piece all squared up. We got our little model here, and one of the trickier things to do is kind of figure out what order of operations we want that's going to allow us to hold the part the easiest and all that kind of stuff. So I think the first thing I'm going to do is cut this inside notch here. That way when we cut this radius, we can flip it and hold it in the vise this way, which will give us a nice area to cut the radius and cut this big heavy chamfer that we have here. So I think first things first, we're going to cut this notch out. So we'll get some parallels, set the block up in this vise, and start doing that. One of the other cool things about drawing these parts in CAD and 3D printing them is it also gives us these nice mechanical drawings, which we can use to follow while we're machining the actual part. So just another little benefit of taking the time to do the CAD. So first things first, we're going to find the front edge of this so that we have a 0 for our digital readout, and that'll allow us to know how far in we've got to go to cut this notch. Alright, so this is a 1/4 inch edge finder. So if we swap this out, with this end mill, which is 1 1/8 inches, and we move the table back 7/8 of an inch, 875, and we 0 our DRO. Now we're to the edge, I'm sorry, half of the 875. So that's 437.50. You always got to remember to do the radius of stuff. Not the full diameter when you're working with this, because it's halves. And then 0 out again, and we've got our edge. So we know, because we have this part here, that we want our remaining flange to be 681 thousandths. So you take the block dimension, which is 1 inch 943. Grab your calculator. Got a new phone. I gotta find where the calculator is. Here we go. Okay, so 1.943 minus 683.683, and we know that we want to go in total cut depth 1.26, so basically 1 1/4 inches. And then we also can check our part or our drawing to know our depth is going to be 1 inch 135. So what I think I'm going to do is start at my depth and then work my way in back and forth to cut the part. So I'm going to go ahead and move us in 25 thousandths. And then just kind of touch off. Zero out our Z, and we know we need to go 1 inch 135 up. Alright, so we stopped here. I'm going to take a measurement we've cut 1 inch 200 thousandths, so we're getting real close. Gonna measure up our model again, zero our indicator, come over here, and it looks like we need to take about 64 thousandths off still. So we'll zero that out. I'm going to cut it in 2 cuts since it's finishing passes. I want to have a nice clean surface finish. So we'll go 30, and then, or we'll go 34, stop, measure again, and then take the final cut.
So what you did, you work on your shot, you work on your shot. Can't work out.
Alright, so our first operation is complete. You can see here, we got our piece underway and making good progress. So I think next thing I'm going to do is turn it up here and center drill and drill this hole while I still have a nice square part to hold on to. Get these parallels out of here, change out for a little thin one. Alright, we got our edge found, our center found. Now we're going to go ahead and drill our hole. So I'm going to look at our drawing here, figure out we're going to come in 650 thousandths, I think. Yep. Center drill. We're going to drill this out to a 3/8 hole. Alright, so we got our hole drilled and countersunk. Gonna pop this out and trying to think. I think we want to cut our angles on here next. So just gonna lay this on here. Give myself a little visual mark. This is just completely decorative, so it doesn't really matter exactly how it is. So I'm gonna get this set up in here. Just use a little parallel to eyeball the marking so that it looks square. Tighten that up and change back to our fly cutter. Alright, so we got all the top operations done. Next thing we need to do is get our radius, our bottom radius cut here. This was a full like half moon. The 3D print just broke. So we got our 1¼ inch ball end mill. I'm gonna go ahead and get this in here. We're gonna find the edge so we know how far to move in, and once we get the edge found, we'll change out to that cutting tool and start making our cuts. So we're going to just touch off, and then we're going to end up going 625 deep once we find our zero on our Z-axis. Alright, so we got our 1¼ inch radius cut in here, nice and clean. I'm going to pop this out and turn it around so we can get to our front edge. It'll be easier to see. And we're going to change out tooling and cut our chamfer on here to match our sample piece, which has a chamfer on here, which is really just kind of decorative. And but I think it'll add a nice touch to it. So yeah, that'll do it. Alright guys, so we got our first machined motor mount done. I am super happy with this. It still needs a little bit of handwork. I'm going to put a little radius on the top here. Obviously we'll deburr everything, get it cleaned up, and ready to be able to weld it onto our frame when we make our frame parts. But you know, design in my head to a CAD drawing to a 3D print to a piece of billet aluminum. I have to say I'm pretty proud of this. So something I thought would be kind of interesting. We have the other piece that we're going to use to make the right hand side mount. So I just want to weigh this. It is 633 grams, and the new machined piece is 193 grams. So more than 2/3 of the material has been scattered all about the shop as some aluminum snow. So just find that interesting and kind of cool. So that's what we got there. As far as the bill goes this week, all all the aluminum and stuff we accounted for last week, so all we had this week was the machine work time. I had all the tooling already, so we just have 3 hours of labor at 140 bucks an hour, 420 bucks. Brings our grand total, you know, for the week to just the 420, and our build total to $7,555.72. And if I look back, what was this chunk of aluminum? Just curious. Was 17 bucks. So, you know, you're looking at like $450 in time, you know, in parts and labor to make a single motor mount. Is that worthwhile? No, probably not. Not for most people. It wouldn't make any sense. Obviously, I don't pay my own labor to myself. I mean, I guess I do in a way, but not exactly. So, anyway, my point here is I just want people to understand sort of how much it takes to get these type of bikes built. The vast majority of people who have bikes like this, I think, build them themselves because the cost is just astronomical, and most people either don't have that money, or the ones that do choose not to spend it on stuff like this. But anyway, I'm not sure if anybody cares about all this. I find it kind of interesting. I'm always curious what other people think bikes are worth based on the effort and all that stuff put into them. So if you are interested in this, I'm going to keep doing it. And if you're not, then you can watch the videos and click it off before we get to the end here where I talk about this. And if you think I'm insane for spending 3 hours of my life making a complicated aluminum L, then you might be right. But I'm going to keep doing it anyway, probably so. That is it. We are getting out of here for the day. As always, appreciate you guys spending some time with us, following along with what we're doing. I know this is sort of a slow progression. You know, there's not a lot to see here, but if you like machining parts and you like custom stuff, you probably like watching us do this. So that is it. We are out of here, and we hope to see you next time at Gattis Garage.